Hi everyone, Kevin here from the Visibility team with another update. This time I'm going to show you Segment Explorer and Embedded Transactions. Two separate projects we're just showing together for the sake of brevity and time. And we're going to start with Segment Explorer, and I'm going to start right from the top. For those that don't know or those that don't remember, Segment Explorer is a way to figure out how performance is affected by user conditions. There's a lot of things we can't control, like a user's device, where they are in the world, their network conditions, things like that. And there's some things we can control, so certain behavioral paths, specific code that do affect performance. And we want to obviously fix the things we can control and exclude the things we can't, or just find out in general like where our users are coming from or why their performance is good or bad. So say I am on a JavaScript project, here's Sentries, and I see my largest contentful paint is around 3,400 milliseconds, and I see a big red bar here, probably means something's bad. Clicking into it, you're brought to the vital detail page. I'll skip over most of this for the sake of time, and we'll skip past my team's specific key transactions to land upon the first or the most frequent transaction here that's also poor. It's just a little bit over the accepted limit for LCP, but it has a lot of transactions, so it's somewhere we want to go to fix the most amount of, time wasted by our users visiting our site. So clicking into it, you'll see a bunch of things have changed. You'll see alphas and betas and stuff. Today we're just focused on the tags tab and the suspect tags little widget down here. Suspect tags you might have seen before in a previous demo for Tag Explorer, but the changes have been mostly around for tag page, been this LCP element and hardware concurrency are all tag keys you can now click. So for example, if I see LCP element here and I see a tag value, it's kind of interesting that it's 19% slower. It happens quite frequently, but I want to know a little bit more about how it's affecting performance. Clicking on it, we're brought to the tag page. And here we see a heat map of, for this specific tag key, all the tag values and their performance counts within each of these buckets. And this can give you a little bit of an overview of like where performance is going or where the most frequent paths are, either or. For here, what I'm going to do is actually build out a set of user conditions. Because say I want to fix that 3,400 milliseconds LCP, I want to sort of exclude all the things I can't control, like user device settings and things that like are based on heuristics, like LCP element. We want to always look at the same one. So when we're comparing two transactions or we're into the data, we're not looking at things that are different for other reasons, like that we can't control. So I'm just going to go through and click a bunch of the high frequency ones here. You can refine or add things to a filter just by clicking this button, or there's also a cell action. So I'm going to look at the most suspect tags. The most suspicious ones are at the top, meaning they have the largest differences within the tag keys. Here, the next one up, this is a very good example. Your hardware concurrency, so the amount of cores you have, affects your performance. Who knew? Here you can see that 8, 12, and 16 cores, etc. are all quite fast, but you'll see 4 cores in general are skewing a little high. And if we go down here, we can also see the LCP matches that. So here I'm just going to choose 8 cores, and we'll move along to effective connection type. This is a great thing that a lot of people wonder probably about their performance. How are my users' connections affecting the performance I see? Because if they have a slow connection, their LCP will be slow, and we can't really fix that for them. A bar ping for them to upgrade their internet, which is probably something we don't want to do. Here again, I'm going to choose 4G. Most of Sentry users are 4G. And I think I'll probably limit it a little bit more. Yeah, you see some large differences in here. We see some outliers in browsers. So we're going to just exclude everything except for Chrome. So we're left with fairly similar LCPs here in the top 3 or most frequent tag values for the specific view. But we built out a set of user conditions here. They're going to help us narrow down some transactions. In this case, a very specific LCP element. This one's a very good one, I think, because it's H3 is likely a heading instead of something like a loading indicator. So it's likely the page is actually somewhat visual complete. Also, we have hardware concurrency 8 and effective connection type 4G. So it's a pretty performant device with 8 cores likely, and above about a megabyte a second in terms of download speed. And they're using Chrome in case there's any difference in browsers. So here I'm going to try to get a little bit lucky, something I've seen before when I first clicked on this. We're just going to pick maybe some like a fast transaction and a slow one. So this here is something else you can do on this heat map, which is clicking into specific buckets, which will show you a handful of transactions, or view all events, which will bring you to the new all events page. But we're going to use it to pick a slow and fast transaction with a lot of conditions applied to see why they're different. I'm just going to pop into these really quick and see 1.7 LCP. And this one is 6 seconds LCP. Okay, we'll give it a shot. So looking at these, some of the things are fairly similar. They have a little bit of differences in their browser timings, but also something I was looking at earlier was that they had a lot of differences in their HTTP requests. You'll see latest specifically is 700 milliseconds in one and 1500 milliseconds in the other. So comparing these now, we have things that are very similar transactions. They should have very similar hardware concurrency, so same amount of cores. This is reasonable download speeds, so there might still be latency. We don't have a tag for that explicitly. And we just wonder why. At this point, normally before, you would have to go out to the traces and stuff and look for, like, dig into why this latest HTTP request we're looking at here, for example, is slower in one than the other. But the new project and the other project I'm going to demo, which is embedded transactions, now gives us a very fast way in line to find more information about why something might be slow. So here I'm going to be able to click events latest, and bam, I see my backend transaction in line. Super powerful, super interesting. And I'll show you this other one before I go on to explain something else. So here you see that it's like 600 milliseconds, 660 millisecond backend request versus 1200 milliseconds. So this is an entirely due to the user conditions. And the way we know that is because the front-end transactions span and the back-end transaction have a little bit of difference between them. And that can be accounted for the user's latency or infrastructure. So it's a really interesting thing to see, which is maybe a little bit trickier before. We can just see that really quickly. In this instance, though, also the backend transaction is quite long, which is longer than the other one, so it's probably behavioral. It's just something we can fix. Scrolling down, we see this really large, this is the first time I've ever seen this, so we'll see what's inside. We see this really large query. If I had to guess, so I've seen this before, and it was because of the from to date, so they're only comparing 30 minutes of time, but their request is still taking 900 milliseconds. I am actually not sure why. That's something that we can look into. I've had an example before where we can find out that the request is due to differences in from date or to date potentially. But now we have two queries that, all the other things aside, are based on SNUBA being different in those two cases. And that is something we can control, unlike things like where the user is in the world. So that's pretty much it for the performance demo. There's other things going to be added to this for Segment Explorer, a couple changes just to clean things up. It's currently an internal, and we need to get those done before we EA, hopefully next week. And the embedded transaction is a separate project and is going to be EA'd, I believe, tomorrow, July 8th. And that's these clickable tags, which you can show more or see a transaction inline. That's pretty much it. Have you any questions, you can @ me in Project Performance or ask anyone on the Visibility team. Thanks.